Hello, hello, hello. Welcome to my latest webinar. I shouldn't say webinar, should I? I'm used to saying that. It's live stream, isn't it? Right, so this is Livestream 28 on my monster series of reviewing an accident investigation report for the Boeing Starliner's propulsion anomalies investigation, propulsion anomalies event. And tonight we're going to continue with the report. We are getting close to the end now, I assure you. After 28 live streams, we are getting close. But before we do that, my name's Simon Whiteley. I'm a systems safety engineer and accident analysis consultant. I specialise in stamp STPA hazard analysis and cast accident analysis, providing training, coaching, consulting, and independent review. And if you're interested in stamp, if you're interested in cast or STPA, you need some help, you're welcome to visit my website, which is whiteley-safety.co.uk. Click this button here, send me a message. I need help now. Stick your details in there, send me a message, and we can set up a call and see how I can possibly help. And likewise, if you're still on your sort of early part of your journey about learning what it's all about, you're welcome to join my free stamp workshop. You can click that button or click the link in the description. Essentially, join a waiting list. And once I've finished getting through these, through these case studies, I'll send an email out to everybody who's registered on the waiting list, and I'll call a free Zoom event, a Zoom workshop, where we can all get together live on video, talk to each other about our experience, and answer any questions that you've got about stamp, STPA, or cast in the context of this case study, which is a space case study. But it is a complex system, and so pretty much any industry that you work in, we can talk about it through the lens of this case study. But of course, it's your opportunity to ask any questions live about your particular challenges. And of course, if you'd like some foundation training, some introductory training, I also provide a one-day foundation training, which essentially takes you from zero, not knowing much at all, not even the acronyms, to somebody who could actually contribute to a stamp or, an STPA or a cast project. So get you on the first sort of rung. And that's essentially a one-day online compressed training. You know, it's pretty intense. The feedback I've had from previous attendees has been fantastic, but it's intense. But if you want to get up the learning curve quickly, within one day, that will set you on your journey. There is a waiting list for that. I'm about to launch some new dates for it. It has been well received, and I would be really excited to see you on there. Fantastic. Right. Okay. So let's jump over to the case study then. So of course we're talking about the Starliner. This is Livestream 28, so I'm assuming you've seen at least a little bit of the others. And of course, if you're joining here live tonight, please type in the chat. Let me know where you're watching from and any questions you've got. And of course, if you want to share some experience, you're welcome to add that to the chat, and I can bring it up on screen and we can talk about it. But just be aware there is about a 30-second to 60-second delay between what comes out of your speakers and what appears on my screen for me to be able to respond. So just be mindful of that lag. So, but thank you for attending. Thank you for watching. Let's get stuck in. So this is the Starliner propulsion system anomalies report from the first crewed flight test in 2024. We've been going through this over the last number of live streams. Where we've got up to is, I'll show you the table of contents. We've done most of the first part all the way through to the main body, and now we're focusing on the appendices. So Appendix G, which is the Crew Commercial Program Star and SDRT report. That's what we're going to focus on today. This is an extended live stream, so I'm going to go as long as I can based on how hot it is in my office. And then Friday, tomorrow, we're going to continue, and I'm going to see if I can do it in 2 live streams. It is a lot to get through. It is 104 pages of stuff to get through today and tomorrow. And if I can't manage it, then I'll just schedule some live streams for next week before I go away. So yeah, fantastic. Let's get stuck in. So this is the Starliner Tests and Anomalies Review Investigation Team Report. So that stands for STAR, as you can see there. Starliner Tests and Anomalies Review Investigation Team. But this report, which is Appendix G to the bigger report, also includes the Starliner Data Review Team, SDRT report as well. So there's sort of 2 compressed together there, and these were delivered in May 2025. There we go. And if you saw the last livestream 27, the last sort of 15-20 minutes, I did a quick introduction to this report, and we'll get stuck in now. I mean, look at the picture. That's a fantastic picture, isn't it? How cool is that? Right then, so this is what the structure of the report is. So we've got the executive summary, which we completed on Monday, I think, or Tuesday. Then we've got the investigative methods, parallel crew flight test investigative efforts, a summary of the Starliner crew flight test, crew commercial program background, acquisition strategy, certification strategy, commercial crew metrics and decision structure, commercial crew timelines, focused crew flight test service module propulsion anomalies timeline, general findings, recommendations and lessons learned, and then some of the specific technical issues. So we've got the helium system issues, and then we've got the thermal issues, the thruster issues. So this is the service module reaction control system and the orbital maneuvering and attitude control thruster failures. Then we've got the Starliner data review team report, which is quite large, quite a lot in there. Then we've got the Star Senior Review Panel. So in addition to the Star Review, there is a Senior Review Panel above them as well, made of senior members. And they've made a small contribution to this report here. Then the conclusion section, which is it's interesting. It's only one page. And then the appendices with various stuff in it. So this is about 105 pages, I think it is. So we will try to get through this as quickly as we can. There we go. So let's get to the beginning then. So let's get a nice pen. Here we go, everybody. Let's just check the chat, see if there's... oh, hello there, Crystal. Good to see you. Thank you for coming along. She says it's highly recommended. I really appreciate that, Crystal. Thank you. But as I say, if you do have any questions or comments, just stick it in the chat and I'll bring it up on the screen. Okay, let's get stuck in. So, Star investigative methods. Special note. The Star investigation team, and I'm highlighting this in orange as a candidate for inclusion in my control structure model. And it's important to recognize that clearly the investigation team was not involved directly in the accident, and so they wouldn't be in the operational control structure. But if we were also interested in assessing or considering the conduct of an investigation, we could include a control structure model to look at the response and recovery from the event, but also the investigation itself and how the investigations, because there's many investigations going on at all different levels of abstraction, and so it might be interesting to have a look at that and see what that structure looks like, whether there is any potential for any independence questions, or we want to make sure we've got a good investigation that's got a good level of integrity. And that can be trusted and learned, that we can learn as much as possible from it. So Crystal says she's hello from Wilmington, Delaware. Thanks, Crystal. The Star investigation team heard many lessons learned from the interviewees that involve the provider, and a summary has been provided to the provider. Not sure what it means by the context of the provider. Does that mean Boeing in terms of the spacecraft, or what does that mean? However, the purpose of this investigation was to identify ways that NASA could have prevented the CFT Starliner propulsion anomalies. So this report will focus on those NASA-related findings. Okay, that's interesting. So we're focusing specifically on the NASA-related findings. So this doesn't include the Boeing executive root cause corrective action analysis, if I recall correctly. Okay, so the evaluation approach is to collect historical data, interview key members with CCP heritage experience, prepare the report, and share lessons learned. So this blanked out area is the Star investigation team members. Fantastic. Completely understand why that will be blacked out. So there's, I'm presuming this is 1, 2, 3, 4 bullet points. So either that's 4 organizations or 4 people. We don't know. Doesn't make a big difference, but it would be interesting to know what their roles were, or what their rough background was. But again, it's not a big deal. So the STAR Senior Review Panel purpose. So this is the senior level review panel. So not the STAR team itself, but a senior review panel to support that. And also the PIT, so that the Propulsion Anomalies investigation that this is a part of, this report is a part of, they also were supported by the STAR Senior Review Panel. Okay, so the Senior Review Panel will check in with the STAR investigation team at regular intervals to provide feedback and further questions to explore during the process. The STAR investigation team will share crew commercial history, DD&T certification analysis, and findings uncovered during the interview process and report building. Sorry, let's just remind myself what DDT is. Where's the acronyms? There we go. Right, DD, D, and T. Where is it? There we go. Look, design, development, test, and evaluation. That's what that means. So I'm just going to stick that on there because otherwise I'm going to forget. D, D, T, and E. There we go. Fantastic. Right. Certification analysis and findings uncovered during the interview process and report building. So the STAR scope. The STAR investigation team, hereafter STAR, because of course this is a space investigation, so it's got to have a space acronym. The STAR investigation team reviewed historical data, interviewed commercial crew experts, and provided evaluations to include exploring some of the following items. Life cycle of the Boeing propulsion system design. So we've got Boeing there, and we've got their propulsion system design. Shared accountability model, including consideration of Boeing outsource of propulsion system to Aerojet Rocketdyne. Okay. Boeing propulsion CDR and subsystem review. So CDR is critical design review. Early trades and design activities under limitations during the Space Act agreements. Propulsion resources applied to Boeing and SpaceX by the program. So when we say propulsion resources, I think reading between the lines, what I think that means is the NASA personnel who were allocated to work on propulsion, the propulsion resources, had their experience applied to both Boeing and SpaceX. And when it says by the program, I think that means the crew commercial program. That's my impression. If I'm incorrect, please give me some abuse in the comments. Let me know. Processes for failure tolerance evaluation. There we go. So that's interesting because you could probably stick STPA in there if you wanted. There we go. I'll just get my pen. See if this works. Processes stamp /STPA. There we go. Given that we can look including failures, but also look more broadly than that. The certification approach. So the hazard report. Verification, closure notice, VCN, variance design and construction standards. And then the phased safety review process, including the hazard report. And then we've got applicable component, propulsion system and space flight utilization knowledge level of personnel, review of Boeing propulsion qualification testing, Boeing service module hot fire testing at White Sands Test Facility, independent analysis of the propulsion system. That's interesting. Interdisciplinary system engineering, access to Boeing and vendor data. Right, okay, that's fantastic. So what does this say then? So investigative process timeline. See, this is handy. This is helpful. I like this. Build timeline of events. Start the 10th of the 28th month. There we go, everyone. Tell me in the chat what month is the 28th month. So October 2024 finished November 2024. So that was 2 weeks. So build timeline of events. So they took 2 weeks to do that. So contracts, procurement, Boeing commercial crew, integrated capability, certification products contract, commercial crew transportation capability, commercial crew requirements, Boeing DD-T&E plus certification for Boeing propulsion systems, program milestones including SpaceX missions. Collect Boeing propulsion system data for background information and develop pre-reading material. CPC summaries and technical evaluations, milestone documentation, deliveries, program control boards, directives. So that was 15th, November 15th. Prepare for interviews, November 15th. Conduct interviews, 18th of November to the 18th of December. And then not the 1st of July, the 7th of January to the 30th of January. Star Senior panel status meetings. So they should be regular meetings, I think. Yeah. So we've got December, January, February. Send first draft of causes themes to review team for recommendations input. So that was January 25. Identify key themes and develop report through early March, presumably 2025. Brief senior review team, CCP management, space operations, mission directorate management, program investigation team. So they're the team that did the main bulk of this report. CCP PCB, so Crew Commercial Program Control Board. Aerospace Safety Advisory Panel, the ASAP. Okay. So there's quite a lot of stakeholders there, as you'd expect. And that was between February and April 2025. And then we've got prepare the out-brief presentations roadshow for lessons learned for other commercially focused programs. And that was April 2025. Release the final report May 2025. That's what that says on the front cover. We've already seen that. Fantastic. Okay, so let's continue on. So the analysis, can't speak today, the analysis methods, processes and tools. The team began by collecting historical data. The STAR researched and reviewed CCP requirements and applicable standards related to propulsion. CCP Boeing SAAs, that was mentioned earlier on, wasn't it? The Space Act agreements, that is. CCP Boeing contracts, Boeing deliverables, including all propulsion-related variances and dispositions, Boeing technical reviews, including select propulsion-related comments, review item dispositions, discrepancies, RIDs. Yeah, there we go. That's familiar. Boeing milestones, CCP processes and procedures, other crew commercial activities, concurrently competing with limited resources. Star built a timeline, Boeing space agreement. What was it? Come on. Space Act agreements and contract milestones. Boeing certification milestones and formal reviews, other commercial crew activities, concurrently competing for limited resources. Star interviewed about 40 key members with commercial crew heritage from Crew Commercial Program, engineering at KSC, so I think that's Kennedy Space Center, JSC, Johnson Space Center, I think, and Marshall Space Flight Center, S and MA. So they are, where is it? I think we've just, there we go. What's that? S and MA. Oh no, it's not. Where was that? I'm sure we saw that a minute ago. Oh, we'll come back to it. We'll come back to it. It's not a big deal. It's probably safety and mission assurance. That's probably what it is. Let's have a see if it's in this acronym list. S&MA. Come on, come on, come on. Where is it? No, it's not in there. Right, okay. At Kennedy Space Center and Johnson Space Center, FOD, including mission operations and crew. I don't think that's foreign object damage or foreign object debris. ISS programs, that's the International Space Station program. Once the interviews were completed, the team documented the results in the final report with findings and recommendations. Okay. So the parallel crew flight test investigative efforts. So NASA and Boeing formed several teams to continue to investigate the failures that transpired during the CFT. Pardon me, Boeing and NASA have a combined testing analysis and hardware team that is in the process of defining hardware and software changes along with associated qualification testing and analyses required to resume Starliner missions. So that's fantastic. And like I've said before, I'd recommend getting involved with that. Get STPA in there because you can better understand what the issues are and then how to solve them, and it will help generate requirements for it as well. Or assess the requirements you've already got. Actually, help with that as well. NASA instituted the STAR investigation team to examine the deficiencies in the NASA certification process to include early design reviews of the Starliner service module propulsion system. NASA instituted the Starliner data review team to examine the real-time flight data analysis from previous orbital flight tests to understand why these anomalies were not identified during the post-flight reviews for previous test missions and ground testing. Yeah, I mean, this suggests, where is it? This suggests there's quite an issue with how that is done. So the question would be, from a STAMP STPA perspective, is what does the control structure look like for the definition, operation, and review of that part of the mission? So NASA chartered the STAR Senior Review Panel, consisting of senior leaders across the agency, to review the progress of the STAR and STR teams and the PIT team, provide feedback and further areas of interest as the team progressed through the investigation. Boeing initiated an enterprise root cause corrective action team to determine why the Boeing development and testing processes that were utilized for Starliner allowed for these design deficiencies to be present for the crew flight test. Boeing has also chartered RCCA teams for each in-flight anomaly under review from the CFT mission. So STAMP, STPA, and CAST could help with all of those things. And I would argue that a root cause analysis approach will overlook critical things that are potentially subtle, but certainly not trivial. After discussion with NASA's technical authorities, so that's the TA's acronym, the International Space Station Program Manager and the Commercial Crew Program Manager, a transition of this work to a NASA independent team was deemed necessary. Sorry, which work was deemed? A transition was deemed. What work was that? The Boeing stuff, or? I'm not sure, it's not really clear. In accordance with the ISS Contingency Action Plan, SSP 50190, the CCP Mishap Preparedness Contingency Action Plan, the NASA Procedural Requirement 8621.1 Delta, and with the concurrence of the SOMD leadership, the programs are convening a PIT using the ISS Program Work Instruction 007 in response to these events. Okay, so the context of this writing was in the very latest May 2025, and this was as the PIT team was being stood up to do their investigation, of which this STAR team and SDRT team report is an appendix 2. So that's why the way this is written is though it's currently going on, when obviously when this report was released in February 2026, it had already happened. Okay, additional commercial crew initiatives. Crew flight test lessons learned process, standard operating procedure for each mission. IFA, so in-flight anomaly review process, standard operating procedure for each mission. Engineering review of previously approved certification products. Okay, right. So let's keep going. So this is the summary of the Boeing Starliner crew flight test. So this is like a timeline description by the sound of it. Let's make sure it's big enough on your screen so you can read it. Right, Starliner launched with a known small helium leak in an service module reaction control system isolated to a single RCS thruster port doghouse manifold number 2 flange. Accepted at 2x5 risk based on worst case leak rates of several thrusters, feed the leak analysis, and result in helium margins. So before I talk about the risk thing, let me just zoom out and grab hold of the jigsaw piece that is always helpful. This thing here, let's get a copy of that and bring it down here. There we go. So first off, let's just have a think for a minute. So Starliner launched with a known small helium leak. So the question is, and the reason I'm doing it this way is just to sort of stretch your mind and keep, I want to burn this model into your brain so you can use it as part of your work. So the first question is, the Starliner launched with a known small helium leak. Fantastic. Okay, so there is a controller that has made a decision that it is apparently acceptable to launch the Starliner. So this is the permission to launch or go for launch with a known small helium leak. So it's known. They know, they've got a mental model. They believe that there is a small helium leak and that for whatever decision-making process they've gone through, that it's acceptable to provide the control action. Now, with hindsight, there's a few questions there that the investigation needs to establish and understand. Why would it make sense for them to do that? And as we go through the rest of this section, it'll become apparent, I expect, what the reasons were and why it made sense. Whether we would agree with that decision after the fact with the benefit of hindsight is a different conversation. But whenever we do an investigation, we have to be really vigilant that we're not falling foul of hindsight bias and unfairly judging the people involved and the decisions they made. The other observation that's interesting is this mention of a 2x5 risk. So I'm presuming, and you might be able to comment in the chat, I'm presuming that there is a risk matrix of some description in a document that's been reviewed and signed off as an appropriate way to make decisions. And they've assessed that risk probably based on severity and likelihood. I'm assuming 5 is the severity. The big number is usually the worst. So severity 5, and I'm assuming it's a 5x5 matrix. I don't know, I'm guessing. And 2 is probably relatively low likelihood. So 2x5 might seem like a reasonable thing to do. But of course, when we're thinking about things through the lens of STAMP doesn't include the concept of likelihood or probability, specifically because when we're thinking about complex systems, especially these kind of systems, probability only really works in very, very specific circumstances. And I would argue that in this case, it's a bit questionable whether probabilistic arguments are appropriately used here. I don't know if it's discussed later on, but it is a bit questionable. I think maybe more discussion of that could be had, I think. Let me know in the comments what you think. So based on worst case leak rates of several thrusters, feed the leak analysis and resulting helium margins. And I think when they say helium margins, I think that's the available supply of helium on board. So if they have a leak, so long as it's not too bad, they've got plenty of helium to be getting on with. But of course, if it gets to a certain level, then that affects the available helium they have for the rest of the mission. So launch. Normal crew flight test launch occurred on June the 5th, 2024. So that's some time information I'm going to mark with a yellow highlight because it's easy for me to remember. Day 1 on orbit. After achieving a successful orbit, 5 additional small helium leaks were discovered. Fantastic. I'd love to know how they were discovered. What was the feedback that the decision maker, the controller, had to make them aware that they got helium leaks? Upon leak rate review and reconsideration of helium margins, a go was given to dock with the ISS. So again, we've got a control action there. Whoever it is that makes the decision to go to dock with ISS, they've made a decision. They've got some beliefs, some mental models based on some feedback or other information from around the control structure that it's the right and safe thing to do that, take that action. ISS rendezvous and proximity operations. On approach to ISS, 5 service module reaction control system thrusters were deselected by the flight software due to exceeding fail-off performance limits. So that's interesting. So the flight software, there we go, flight software. Actually, I probably should highlight that as a candidate for inclusion in the control structure model. So the flight software decided, there we go. So if this controller is the flight software for a minute, just imagine that. So we've got the flight software, and on approach to ISS, 5 thrusters were deselected by the flight software. So the flight software has made a decision based on a control algorithm. It's a piece of software, so there's a programmed algorithm in there that is related to the deselection of the thrusters, and it's due to some form of feedback exceeding fail-off performance limits. So there's a process model inside the software, some beliefs that the thrusters have exceeded fail-off performance limits, or some other related fail-off performance limits have been exceeded, and so the decision is to shut it down. Now that could be a perfectly reasonable thing to do. The feedback from the process, from the spacecraft, the thrusters, it could be valid feedback, and it's done exactly what it's supposed to do, and it's safe. That's great. Now, if we were thinking about this through the lens of STPA, Systems Theoretic Process Analysis, and we were thinking about how would we design the flight software and how would we make it safe, one of the other scenarios we could think of could be, if the flight software has decided that 5 SMRCS thrusters are to be deselected, what if the process model, what if the beliefs were incorrect? What if it incorrectly believed that there were some issues with that there was issues with fail-off performance limits, and it decided to shut down 5 thrusters? What if it decided to shut down all the thrusters or disable them? Can it do that? Is it designed to do that? Is that a safe thing for it to do? What mitigations do we have against these false beliefs? What is the feedback path? What sensory feedback do we receive? How do we know that that's good feedback and that it's got integrity? And I'm just sort of trying to stretch your mind a little bit, just to think a bit about, well, in this particular accident, in this particular scenario, the flight software did something, and is that something in accordance with its its procedure? In accordance with its specification? Did it perform exactly as it was supposed to do, or were there some questions over that performance? And if there are questions, could that reasonably be due to some of these other causal scenarios in this control loop, of which one of those is misleading beliefs? And one of the reasons you might have misleading beliefs could be because the feedback was incorrect or inadequate. I mean, it's always possible, and this is one of the fancy things about doing STPA, is you can postulate a scenario where the beliefs are incorrect. It believes that the real world is not as it is, and that's not due to the feedback. It could be due to a fault with the controller itself. Maybe it's been exposed to high temperatures and it's not performing properly, or there's issues with electrical power supply, or all many weird and wonderful reasons that include failures but also might not be failures, and that's what STAMP is really good at finding. So let's keep going. All thrusters were immediately hot fire tested. So somebody has decided we probably should do some hot fire testing by reselecting, but showed signs of degradation. So they got some feedback that showed signs of degradation in performance. After assessment, a go was given to dock with ISS. So again, who or what is the controller making that decision to go and dock with ISS? Is that the right thing to do, the safe thing to do? You know, what are the questions over that? Starliner successfully docked with ISS on June the 6th, 2024. That's over 2 years ago now. Gosh, time flies. Starliner was determined to be acceptable based on performance to serve as an emergency egress vehicle if ISS if required on the 7th of June 2024. Okay. We've got a comment in the chat. Let's just have a look. What does it say? Hi, Crystal. Thank you for that. When the bad outcomes happen, were any of them actually thought to be able to happen? That's a rhetorical question which leads to not planning for worst case scenario. Yeah, absolutely. I mean, it's not really clear from the report how far they anticipated some of these issues. I'll be quite honest, I didn't get a warm feeling. I mean, I'd expect worst case scenarios to be considered, but I didn't get a warm feeling from the tone of the reports that was considered in a lot of detail. I could just be misinterpreting it, but it didn't give me a warm feeling, and I anticipated it would. But it's important to realise that this investigation report, as I understand it, was written by a fantastic team of people who were doing their full-time job as well. This was like bolted on the side, and they did it over a period of a couple of months. So to create a report of this detail with all of this stuff in and do all the investigation, do all of the interviews and then write it all up is quite fantastic alongside a full-time job. So I'm not giving them, abuse for that. They did really well given the context. Okay, so mission testing then. Extensive ground and flight testing was performed during the mission to understand root cause for the helium leaks. So that was one issue, the helium leaks, and the RCS thruster fail-offs, and potential interrelationships between the two, and determine flight worthiness to return the crew. Excuse me. It included 2 separate docked hot fire tests of the service module RCS, where 27 and 28 thrusters were nominal, and extensive ground testing at the White Sands test facility of a single engine with disassembly and inspection. I mean, this I don't know too much about it, so I'm a layperson for all intents and purposes, but it just sounds really dodgy to me. You've got a spacecraft that's misbehaving, docked to the ISS with people on board and all the billions of money invested, and you're going to do some hot fire tests while it's docked. I don't know. It'd be interesting to know what the justification was for that, But, it'd just be interesting. If you know in the comments, please let us know. Tell us some detail about this. Does it sound as dodgy as it is, or is it actually, it's perfectly fine, Sci. Don't worry about it. It's not a big deal. Okay, so thrust. Yeah, we've done all that. Right. Note: there was a gap in the reaction control system qualification for the mission profile. Was identified and considered. I mean, that is really interesting. Why was there a gap? How did they find themselves in space with a gap in the RCS qualification? I mean, that is a huge question for the investigation. Agency reviews. Flight rationale was prepared for both the Service Module Reaction Control System helium and Service Module Reaction Control System thruster anomalies, with Boeing's recommendation to undock and return nominally with the crew. Okay, so this is the Boeing recommendation. So if we take our little jigsaw piece for a minute and we imagine this controller is Boeing and they provide a recommendation, a control action, or some feedback depending on how you want to treat it, and that feedback is to recommend to undock and return nominally with the crew. So what decisions were they making? What was that decision based on? What information did they have? What beliefs did they have? What feedback did they have? Was that a sound decision that they were making there? And then it goes on to say NASA did not accept the flight rationale and decided to return Starliner uncrewed. There we go. So if this is NASA, they've said, no, we're not doing that. Undock and landing. So Starliner undocked, re-entered and landed successfully as predicted on the 6th of September 2024. There we go, that's really exciting. Right, Boeing Starliner successfully launched atop a United Launch Alliance, ULA, Atlas V rocket. Wow, how cool is that? And reached orbit on June the 5th, 2024. The Starliner crew flight test launched with a known small helium leak isolated to thruster P2D2 flange in a service module reaction control system thruster. Leading up to the launch, the 2x5 risk was accepted based on worst case leak rates of several thrusters, not just one, by the Commercial Crew Program Control Board at PCB 24196. So this, if you're thinking about the control structure for those decisions about accepting those risks, it is the entity, the Crew Commercial Program Control Board, that made that decision. And of course, if you zoom into that board, there's going to be various stakeholders involved in that. And I imagine that they've interviewed the members of that board to understand why it made sense to do that. So that was May 23rd, 2024, with a crew flight test constraint that lack of two-fault tolerance for deorbit be accepted at the pre-CB program control board prior to the crew flight test. That constraint was cleared the following day when Boeing CFT CST 100 risk acceptance for service module system being one fault tolerant for deorbit was accepted at PCB 24199 on the 24th of May, so the next day. A Delta Agency Flight Test Readiness Review, FTRR, was held at COFR 24, whatever that is, May 29th, so the day after that. The week after that. And the poll was unanimous to go for launch, with one commercial crew exception regarding the Boeing crew flight test service module helium leak management, which was subsequently signed on May 31st, 2024. It's interesting that it says there was only one commercial crew exception, given that over here it says there's a gap in the RCS qualification for mission profile. I would kind of have assumed that gap, if it was formally controlled and management were aware of it, it would be mentioned here. So there's a question there over how those that qualification gap was actually, did they not know that they had a qualification gap? Or did they know and it just got lost in the sands of time? What is it about this gap? This is really interesting. Right. So performance issues were identified in Starliner's service module propulsion system during free flight rendezvous and post-docking with the ISS. 5 additional small helium system leaks, 3 pre-docking and 2 post. Fail-offs of 5 thrusters. Operations teams performed a series of hot fire tests, which re-enabled 4 of the 5 thrusters. Upon review, a go was given to dock with ISS. During ISS rendezvous and proximity operations, 5 SMRCS thrusters were deselected by the flight software due to exceeding fail-off performance limits. All thrusters were hot fire tested by reselecting, but showed signs of degradation. Starliner successfully docked with ISS on June the 6th, 2024. Yeah, okay, right. So the Starliner mission management team meeting. So this is definitely a candidate for inclusion in the control structure. On the 7th of June, so this is the day after it successfully docked, determined Starliner was acceptable to serve as a safe haven emergency egress vehicle from ISS if required. So again, if we're thinking about the control, if we're thinking about the control loop and the controller, and this, if we think this is the Starliner mission management team and they've made a decision, they determined, well, how did they determine? What was the decision making they went through? What were the available, what were the mental models? What were their beliefs? What was the available feedback supporting those beliefs that would make sense to determine the Starliner was acceptable to serve as a safe haven emergency ingress vehicle, given all of these issues that went before? And not just the issues that went before, but how those issues were discovered over the timeline. Because there's more and more issues stacking up as the mission proceeds. While safely docked to the station, NASA and Boeing performed extensive ground tests and flight testing and analysis to evaluate Starliner's performance. Understand root cause. Again, if you're looking for root cause, you're missing half the picture. This is why I recommend stamp and cast, because it will help you uncover much more than just a root cause. And determine flight worthiness return crew. Testing included 2 separate docked hot fire tests, where 27 of the 28 thrusts performed nominally. NASA and Boeing conducted an extensive fault tree investigation, working closely with Boeing's propulsion system suppliers, conducting additional in-space hot fire testing, conducted additional ground testing at NASA's White Sands test facility in New Mexico, completed additional studies of system fluid and mechanical operations, and established the probable cause of the helium and RCS thruster failures to better inform performance predictions for the return flight, and brought in independent propulsion system experts from across NASA and the Boeing enterprise for an independent assessment of the risk and recommendations on the path forward. Okay. So again, it'd be nice if it said we've done an extensive STPA or a cast. Maybe next time. Hopefully there won't be a next time. During this time period, extensive ground testing of a single engine, including disassembly and inspection, was conducted in conjunction with a review of the original RCS qualification testing, in which a gap in RCS qualification for the mission profile was identified. Yeah, so how did we get ourselves in this situation? How was that missed? That is a key element of this investigation, I think. But again, you know, if we're using fault tree analysis, we shouldn't be surprised we're missing stuff. We shouldn't be surprised. I've reviewed many fault trees over the years and done a few myself as well, and I can't recommend just doing a fault tree anymore. Do an STPA as well. Okay, commercial crew worked with the ISS program and SpaceX. Commercial crew worked with the ISS program and SpaceX to provide operational flexibility, adjusting the scheduled crew handover with SpaceX to alleviate schedule pressure and compress timelines. In the end, the commercial crew recommendation to return Starliner uncrewed was presented and unanimously accepted by agency leadership, by the Boeing CFT Delta Return Agency, FTRR, on August 24, 2024. Ultimately, Starliner completed an uncrewed autonomous docking from ISS on September the 6th, followed by a successful deorbit, spacecraft separation, descent, landing and recovery on September the 7th. Overall, Starliner performed well across all major subsystems in the undock, deorbit and landing sequences. Yeah, performed well. The service module propulsion system performed well. Helium system leaks remained in a family requiring no in-flight management, and service module thrusters remained healthy. However, the crew module propulsion system experienced the crew module propulsion system. So this is different. This is a different system to the SM. So this is the service module. Wherever it says SM, it means service module. Whereas this crew module, CM. The crew module propulsion system experienced a failed RCS thruster. Boeing performed an inspection and began an investigation immediately following recovery of the capsule. Oh, so they've got the capsule. Right, that's, if I remember correctly, the service module is burnt up, but the crew module obviously survives. That's what you want it to do. You want it to survive. NASA was fortunate to have instrumentation and data collection capability. Yeah, this is fantastic. You know, you need flight data, so to speak, that allowed most of the return test flight objectives to be met, even without crew on board. As a result of the extended flight test duration, numerous lessons were documented that will benefit NASA and Boeing in support of future Starliner crew rotation missions. Okay, let's just check the chat, see if anybody's given me any abuse. I'll just have a quick drink. Just want to say hello, viewers. Thank you for joining me. If you'd like to type in the chat where you're watching from, that'd be really cool. I always like to know where people are watching from. It's always interesting. You know, the ability to broadcast from my office to people around the world, it just still blows my mind. But yes, right, let's keep going. So the post-mission summary. A number of flight test objectives were completed, even though the Starliner spacecraft was returned uncrewed. CFT mission flight test objectives, so FTOs. So FTOs, all of those, 24 partially met, 12 impacted by uncrewed duty, uncrewed return. Completed pre-flight objectives. Executed activities involving the crew and critical ground support personnel. Successfully executed astronaut suit-up procedures and transport to pad. Successfully executed crew ingress, hatch closer and leak checks. Successfully executed critical safety tasks in the cabin, so evaluated spacesuit and seat functionality, assessed the in-cabin environment and life support systems, manually armed the launch abort system, established effective and reliable in-cabin communication with the crew, gained experience working through pre-launch issues and executing crewed launch scrubs, completed docked objectives. Starliner successfully completed an autonomous docking. Nominal hatch opening and closing operations essential for visiting vehicles were performed. Configured the spacecraft in and out of quiescent operations. Fantastic. Right. Completed critical activities like the transfer of energy management, emergency equipment and other cargo. Successfully executed safe haven exercises and a real-life demonstration of crew procedures to power up the spacecraft. Shelter inside the cabin and prepare for a possible undocking. God, that's a bit of a interesting flight test point to perform. Getting ready to undock, but not actually doing it. Can you imagine an inadvertent undocking? Anyway, significantly more data obtained than originally expected, docked for 3 months versus 10 days. Thermal and power were able to collect data at maximum beta angle and multiple beta cycles. Lessons learned were captured for improvements in build, test, and operations. Model correlation data is being incorporated to reduce uncertainty in predictions. Fantastic. Okay, well, let's just go back to the table of contents and mark off where we've got to. So we've talked about, yeah, I think that's where we've got to. So let's keep going. Crew commercial background. Here we go, everybody. So NASA's Commercial Crew Program was established to facilitate, the development of a US commercial crew space transportation capability, with the goal of achieving a safe, reliable, and cost-effective access to and from low Earth orbit and the ISS. Sorry, headphone users, I didn't mean to smack my microphone then, sorry. From the program's inception, NASA has remained committed to ensuring that the requirements, standards, and processes for all commercial missions are held to the same safety standards as government human spaceflight missions. NASA also remains accountable to its international partners for the safety of crews travelling to and from the ISS and NASA missions pursuant to its international obligations. NASA plans to fulfill these obligations through certification of a commercial crewed transportation system, which requires skilled NASA insight in the early crewed missions and continued oversight. So insight and oversight and surveillance for crewed operational missions. Commercial crews serves a distinguished role in sharing NASA's human spaceflight expertise with commercial providers who strive to develop crewed transportation systems while balancing NASA's responsibility to ensure the safety of its crews. So what we're saying there is sharing NASA's expertise with commercial providers while balancing NASA's responsibility to ensure the safety of its crews. Maybe I'm being a bit pedantic, but why do they need to balance safety of the crews with sharing their expertise? Surely one takes primacy over the other. Rhetorical question. It's just interesting that it's laid out like that. Commercial crew leverage the experiences of the NASA commercial programs, including commercial orbital transportation services, cargo resupply services, and launch services program, and led the change in NASA's human spaceflight culture in its approach to managing the program's efforts. The table below captures full-time equivalents for NASA's existing spaceflight programs, demonstrating the efficiencies of the crew commercial program. So this is 2016. Let's zoom in a little bit. So we've got 2016, 2025. So we've got Orion Space Launch System and EGS. I can't remember what that is. So total for 1, LSP total, CCP total for 2, CTS. So these people, 2000 people, so it's got bigger and bigger and bigger, then it's getting smaller and smaller and smaller. And that's about the same, plus or minus 25, 50. Okay, well, why are we telling this? No, so full-time equivalents for 2025 are provided as end-of-year projections based on full-time equivalent actuals as of April 2025. Why are you telling us about the size of the teams? Why do we need to know that? So LSP is the launch services. So this is the gosh, it's hard to use this pen. Got one of these digital pen things, these drawing tablets, and I just can't use it. Oh, there we go. Launch services program. So that's that bit down here. And then the EG. It's not really explained, is it? Is this a particular... Anyway, I don't think it really matters too much to the investigation what that detail is. So let's just keep moving on. So the commercial crew program was expected to manage development. Was expected to manage development and operations for 2 crew transportation systems for only a sixth of the annual FTEs of NASA's other human spaceflight program, which is working collectively on a single crew transportation system. The math doesn't seem to be mathing in my brain. How can you do something so challenging with a sixth of the people and do it for 2 systems? It just doesn't seem quite right. Just logically, it doesn't seem quite right. Okay, so first, NASA required its CCTP CAP contractors to integrate and deliver a complete crew transportation system. This important aspect eliminates the need for NASA to perform the complex systems engineering and integration functions for major elements of the CTS, thereby enabling CCP to perform its primary function. Right, here we go. This is why. Primary function is to oversee contractor performance for crew safety and mission assurance with fewer personnel. Okay, so if you've got less personnel and the focus is on oversight, well, first off, you've got a craft into space that wasn't qualified. There were gaps in its qualification. So why was that? And that's not pointing at NASA. That's pointing at all of those stakeholders. How did that get through? What were the issues with the control structure that allowed that to happen? And then again, the change from doing the engineering to providing oversight, that change, why was that change authorized? Why did that make sense? And with the benefit of hindsight now, is that going to be revisited? Is that going to be changed? Is that going to be reconsidered? Perhaps it should be. You know, there must be some complex systems engineering and integration done. The question is it done by the right people with the right experience, the right organization? Because it has to be done by somebody. You can't just oversee it and that work not get done. It needs to be done somewhere, so somebody needs to take that responsibility on. So if you built a control structure model that covers the contracts, I touched on this in probably video number 2 or 3. If you did an independent stamp control structure model for the contracting structure, you might actually find some structural weaknesses in that, some flaws, which will need to be fixed. Otherwise, these kind of things are going to happen again. Second, commercial crew has accomplished its efforts through a shared assurance model that minimizes overlap of responsibility within NASA by utilizing the most knowledgeable skills to support both oversight and insight activities. Oversight and insight are different functions. They might require different people with different experience and capabilities. To provide oversight, you don't necessarily need all the technical detail, but to do insight, you certainly do need to have that technical experience. While meeting agency requirements and maintaining necessary checks and balances, NASA implemented the shared assurance model through oversight activities which had been pre-declared through the CCT CAP contract. The shared assurance model ensured, I don't agree it does, it didn't, because we've had an issue, so it doesn't do that. Ensures that checks and balances are in place. No, they might be in place, but they're not effective then. Through clear delegations of authority while eliminating overlapping efforts. Yeah, I'm sorry. Based on what I've read in this report so far, I don't think that actually works. I think it needs seriously looking at carefully. What is the control structure that model presumes or enforces on the stakeholders involved? And is it actually adequate to ensure control of hazards and response and recovery to their consequences? I'm not really sure it does do that. I mean, it sounds like a great idea, but it doesn't sound like the control structure that underpins it as implemented is actually working, because of course we've had this incident. And it's not just one incident. There was previous anomalies on the previous 2 flights as well. So, you know, the shared assurance model ensured that checks and balances are in place. But are they actually working? Are they actually the right checks and balances? That's what the investigation should go and look at. An investigation should go and look at. Okay, so NASA's accountability for mission success comparison. Here we go, figure 85. Right, so we've got, what's this graph? What's the is that time, is it? And what's this? Level of mission assurance effectiveness crew commercial provider must obtain. They must obtain it. Surely they must provide it, or it must come from somewhere. That doesn't make sense. I mean, again, I'm a layperson reading a technical report. I've not been involved in reviewing or generating, so of course I'm going to probably ask stupid questions because it doesn't make sense to me as a layperson. But it just doesn't feel right, this thing. Because when you move fundamentally, if you're eliminating the need for NASA to perform the complex systems engineering and integration functions, fine, but somebody still has to do that somewhere. That responsibility and the necessary resources has to be allocated to somebody else to do that. If you're just going to become an oversee contractor performance, of course you don't need as many people, but as soon as you don't need the people with all the experience, they're basically gone, unless they go and work for the contractor. And people age out. They don't like getting messed around, and then they'll just leave and you won't have that experience anymore. And then you've got to relearn those things, those issues. So the STS approach, so I'm presuming that's the Space Transportation System, which will be the Space Shuttle Orbiter, if I've used the right terminology. So transition from full government oversight to USA, consolidated contractor, with USA assuming more accountability and NASA ownership of the fleet. Okay, so that's why it's reduced. Then we've got the level of NASA technical oversight. So it's getting less. So this graph, the vertical line, is the level of technical oversight. And this is the switchover between NASA oversight, technical oversight, and the commercial provider. So the CCP approach, procure commercial crew services with medium level of technical oversight. Well, I would have thought medium's about here, isn't it? In the middle. I mean, I suppose that's medium of the medium. Is it upper medium? I don't know. NASA's LSP approach. So that was the launch services thingy, wasn't it? LSP, Launch Services Program. So the Launch Services Program approach is to procure commercial launch services with medium level of technical oversight. But if you're talking about procuring a service, that doesn't necessarily involve too much technical oversight, does it? And we shouldn't be mixing, launch services with designing and developing a spacecraft. One is design and development, one is consumption of a service. They're two different things. Commercial communication satellite companies approach. Again, that's not human space flight, is it? Unless you've got nuclear batteries and all that kind of exciting stuff. CRS approach, procure commercial launch services with limited level of technical oversight. I don't know. This fundamentally seems a bit. When we say technical oversight, what do we actually mean? Do we mean that the NASA fantastic engineers actually look at support the design and development of a system, or do they review the design and development of it and say, yeah, that looks pretty good, or no, we don't like this? And how does that differ from acquiring a service, a provision of a service? Because if you're talking about procuring a commercial cruise services, so a commercial organization provides the service of getting your astronauts into space and back safely, then should you really be involved in the design and development of it? Should it be up to the commercial provider? And I know earlier on it said, well, hang on, the point is for NASA to provide less oversight whilst at the same time bolstering the technical capabilities of the crew commercial program development, share their experience. But they're two distinct things. They're not, it's not like a weighing scale. They are two distinct functions. Yeah. I'm just wondering, and I'm just thinking out loud here, just without really thinking too much about it. I'm a bit uncomfortable with this. I got an impression that this is a contributor to what's happened, and I think this should be explored using STAMP. Because you could take the contracts. I said this in one of the early live streams. You could take the contract, build a control structure model from the content, see where the gaps are, see where the roles and responsibilities are unbalanced or if there are gaps in those. And then you could make recommendations to make it better and improve it. But fundamentally, I'm not sure, based on this language, I'm not sure this really actually deals with the technical risk and the safety engineering of the system or the way operations are done. I think it's more complex than this. This is not does not give me confidence. No offense to anybody or the people involved in creating it, but if I was asked to independently review it through the lens of STAMP, already I'm not getting a warm feeling. Third, hang on, what was second? So that was first. 2. You see, it might eliminate the need for NASA to do that, but somebody still has to do it. And if they're not doing it very well or they've not done it before, then that's not really a very smart thing to do, I don't think. So third then, the commercial crew has relied on leveraging best talent, skills, facilities and other resources across the agency, regardless of location, including cross-center supervision. Since inception, commercial crew applied a temporal model of full-time equivalent utilization across field centers. The oversight insight used by commercial crew engages technical experts and reach back from other NASA organizations, resulting in the signing of the best person for the task, which was also successful in LSP, the robotic spacecraft projects, and the COTS CRS teams. Right, so it was you see this here. If something was successful in other applications, fantastic. But are those other applications equivalent to, human spaceflight and the complexity involved and the safety cases and the levels of risk and all of that kind of stuff? Because I'd argue they're probably less risk projects. They're not really too, well, of course they're going to be upset if they lose some of these missions. But if you lose some missions with people on board, the level of rigor of the engineering and the oversight and insight should be commensurate with that. And so using that as a sort of a justification, by the way, this was successful on these completely irrelevant programs that are not the same in terms of engineering or scale or complexity, that kind of undermines the credibility of that particular statement. Maybe I'm being a bit picky there, but we have to measure, show compare apples with apples and not, from an engineering perspective, we shouldn't distract ourselves. Commercial crew leverage the solid base of expertise from multiple field centres and has a continued an outstanding record in design, development, test, evaluation, and operation of 2 crew transportation systems in parallel. Commercial crew provided the agency with a single focus for developing commercial crew transportation capabilities and maximising the opportunity for industry to operate the systems without dependence on government assets, all while ensuring compliance with NASA's human rating requirements. I don't know, that sounds like a really positive spin on things, really positive reflection on things. But yet we're in the aftermath of 2 flight tests that were a bit dodgy and then a crewed flight test that probably shouldn't have happened. So is outstanding record really the right thing to say? I don't know. Not sure. I think someone's chatting me. Let's just have a look. Let's have a drink. Just bear with me a second. I guess I've been talking on mute for a while, haven't I? I just realised. I wonder how I managed that. Did I knock the microphone? What did I do? Oh my gosh. Just bear with me. So I'm just checking back. It seems I've been talking on mute. So I went on mute 23:32 minutes ago. 23:32, and the time is where are we at now? No, I went back on. Yeah, so the last 20 minutes or so. All right, 1840. Ah, dearie me. There we go. Human factors, everybody. Human error. Right, let's just try that again, shall we? So I'll plug my headphones into charge. We'll see if I can hear myself. Is that working? Let's just see. Hello, hello. Test, test. There we go. Got some noise. Right. I'm very sorry about that. That was like 20 minutes, 25 minutes of me moaning and going on. What I'm just going to quickly do is yeah. Well, it's 2 pages. We'll keep going. Yeah, I don't know. I can't fix that. That's not something I can fix. I think what I'm going to have to do is have a think about how I use this microphone and the mute feature, because a number of times I've tapped it by accident and it's muted. So maybe I shouldn't move my hands around. Maybe I should hold them on my desk. But anyway, what I was saying is let's keep going. So commercial crew integrated capability. NASA provided limited technical assistance focused on enabling significant progress on maturing the design and development of an integrated commercial space transformation system. So these are sort of, it seems that these are, it says SAAs. What was SAA? It was on the first page, wasn't it? It was on the first page, Simon. SSA. There it is. Space Act Agreements. So that's what SAA is. So early trades and design activities under limitations during Space Act agreements. So the Boeing Propulsion CDR and subsystem reviews took place during that period of time. So if we go over here to the timeline, like this, there it is, sorry. So in 2010, we've got commercial crew commercial development round 2, integrated capability, transportation capability. So we've got 5 partners. We've got Blue Origin, Boeing, Paragon, Sierra Nevada, United Launch Alliance, and the scope is crew transportation system technologies and concepts. Total amount awarded 50 mil. CC Dev 2, 4 partners, Blue Origin, Boeing, Sierra Nevada, and SpaceX. Elements of crew transportation system, so that was 315 mil. And then CCI CAP, 3 partners, Boeing, Sierra Nevada, SpaceX, integrated crew transportation system. Total amount, 1,167,000,000. So that's quite a lot. And then CPC Phase 1, 3 providers, Boeing, Sierra Nevada, SpaceX, and that's early certification products, 29.5 million. And then CCT CAP Phase 2, 2 providers, Boeing, SpaceX, full certification plus initial ISS missions, total amount awarded 6.8 billion. So that's quite big. That's quite a lot. Stamp and STPA could have been used right up front, could have been implemented up front. And I recognise 2010. So Stamp first started being talked about in sort of 2002, 2004, maybe even earlier. I first discovered Stamp, STPA and CAST in 2010, October. And then my first MIT workshop was in 2014. I've been every year since then. And of course, this is like a couple of years worth of, what is it, 1, 2, 3, 4, 5 years worth of work. Yeah. I mean, they've done a lot in a short space of time. That's quite impressive. But then, the last sort of major mega project I was on was a ballistic missile submarine program, and that's just absolutely mind-blowingly complex. The system is complex, but the organization and the program is just ridiculous. It just blows your brains. I would be interested to know, if I was doing this investigation, I would have a timeline like this, and I would want to see where the safety analyses activities were and where the documents were. The fault tree analysis was reviewed, completed, how the requirements were flowed down, because that would give you an insight into how that fits into the certification. If you want to do a how's safety going on my program, why is it so expensive and painful, and why have we got delays, go and talk to the safety engineers, ask them to explain how the safety program really is. And don't be afraid of what they say. Ask them the questions, see how that fits in the timeline and how much faffing around they have to deal with. I'm not assuming that's what's happened here, but I'm sure that would be a good indication. Right, so what have we got? That's still working, isn't it? Let's see. Yeah, I can hear myself. It's working. Let's just mute that so it's not distracting. There we go. Right. So in July 2012, NASA approved the revised. Oh, hang on a minute. So this was to 2016. 2012 is there. Okay. So 2012, NASA approved the revised certification strategy. Oh, so they've changed the certification strategy in 2012 for the contract phase. So this was like 2 years, 3 years into the contract. So they've changed. You see, the thing is, it's not just about changing a strategy. It's about recognizing that strategy has implications for the control structure, the design development control structure, and then how you operate the thing. And as I said, the certification strategy we discussed that you probably didn't hear because I was on mute, I wasn't convinced that was really that good from how it's described. And I'm just wondering if yeah, because I might have missed it. It might be muted, but I was basically going to town on this concept of shared assurance and whether it's actually appropriate. There we go. Because it says there, although certification maintenance is the responsibility of the commercial provider, NASA maintains oversight approval authority for any changes. And so you've got responsibilities for doing important things that are allocated across different stakeholders that have competing objectives and goals. And is that really the right thing to do? Is that really appropriate? Maybe it's a rhetorical question. Let's keep going. Right. So on this diagram, we've got 2012, 13. So there's the preliminary design, critical design, and then certification. So we've got industry technical maturity. Actual schedule will be commercial provider specific. So certification for ISS crew transportation, phase 1, phase 2, alignment with NASA certification requirements. So we've got an evaluation team, certification products contract, request for proposal, presumably, a verification, validation, test, and final certification contract, certification to include at least one crewed ISS mission, number of awards to conform to budget, ISS crew transportation services, request for proposal, ISS services contract. Revised certification strategy 2012. So why did it need to change? What caused that change in the strategy? And how does that impact the safety of the program? because I've seen it multiple times now. You get program managers and project managers faffing around with the program, and it causes a lot of headaches and difficulty for the engineering teams, and especially the safety engineering teams, to be able to get the work done and get the work done in a reasonable amount of time without too much undue pressure. And I'm just wondering how that was sort of managed and coordinated. I mean, were these issues baked into the design in 2013, 2014? It sounds like some of them were. Anyway, the certification products contract began. Yeah, that's that one there. Look. Certification products contract. There we go. Began the initial certification efforts to enable an efficient transition to the CCT CAP contract and provide a certified capability for ISS missions. The effort focused on maturation of selected critical safety and engineering products, including alternative standards, hazard reports. So they are the ones that I would be interested in seeing and reviewing. Verification and validation plan, NASA requirements, requirement variances, and the certification plan. NASA technical assistance slightly increased, related to reviewing and maturing technical aspects. Of design options, enabled technical interchange about meeting NASA requirements under contractors' certification approach, allowed for review and approval or partial approval of mature alternative standards and variances for inclusion in CCT CAP. The CCT CAP acquisition schedule was aligned with CPC final delivery schedule and time frame for NASA feedback to optimize offer or final proposal revisions. So mute. Unmute. Contract type. Firm fixed price. Performance based. With fixed price, indefinite delivery, indefinite quantity elements. You see, I wonder how much of this kind of contracting actually undermines safety and makes it very difficult to run a business and make a profit. Because if it's fixed price, you want to try and do as little as possible until you can start making some money. But obviously, if you're designing a spacecraft, you need to do all of that heavy lifting up front. Anyway, contract period. Date of award through completion of the last required milestone in attachment J03 Appendix A. Okay, develop and certify a CCTS crew commercial transportation system that can provide safe transportation of NASA crew to the International Space Station as soon as possible. 2017. The CTS development enabled the purchase by NASA of commercial services to meet NASA's ISS crew transportation needs once the capability is certified by the agency. Okay. So there's a lot there to sort of think about from a commercial perspective. So that was, let me just finish that off. So that was the acquisition strategy and CCP contracts. Acquisition strategy and CCP contracts. Actually, I should just zoom out and do it myself, shouldn't I? There we go. Acquisition strategy. There we go. Certification strategy. Here we go, everybody. Certification strategy. So this diagram, I think we talked about on the first couple of live streams. So the commercial crew certification approach was different than traditional human spaceflight programs utilizing a risk-based approach. Okay, so again, I'm emphasizing the original control structure has been changed to a new one with a different approach. So how was that change managed? How was that dealt with? What was the control structure for that change? So we've got shared accountability in yellow, allocates greater accountability to industry by CCP design. Shared assurance minimizes overlap of responsibilities by utilizing the most knowledgeable skills to support both oversight and insight activities. Risk-based insight allows decision-making process to drive insight, surveillance, and product assurance actions, activity to ensure mission success. Yeah, this is what I was moaning about when I was muted. I don't think this change to the control structure is appropriate. And evidence of it not being appropriate is we've had these issues, I'd argue. So I think this needs to be examined. And I know I can appreciate that as politically sensitive and all of that good stuff. But if we want to stop wasting billions and lots of time and potentially killing people, I think that's necessary. So yeah, I'd build a control structure for these two, and I'd see what the differences are and what features from this one are missing from this one, or are different or not as adequate, shall we say? I mean, that's quite a difference, I would argue. By using a non-traditional approach featuring public partnerships, NASA is facilitating the development of several transportation systems by partnering with commercial companies for human spaceflight services to and from low Earth orbit and the ISS. The key outcome of developing a commercial provider-based capability is the overall cost effectiveness of the resultant CCTS. Is that really the case, though? Is it really going to be cost effective like that? NASA expected to achieve cost effectiveness through the adoption of several key paradigm changes during the system design and development. Non-traditional contracting approach which enables contractor-owned and operated designs, competition by multiple industry providers, mature and stable requirements managed at a higher level. Really? Really? Is that really what's going on? Or is it just the unstable, difficult stuff, immature stuff is shoved further down? Smart application of design and construction standards. Okay. Efficient and effective government insight and oversight. Really? Lean, oh God. Lean and agile project management with a small footprint. Yeah, okay, sure it is. I've seen that tried to be implemented on many big programs, and every time it's just generated more work, more admin, faffing around, and actually stopping people doing actual meaningful engineering. And so I would be very interested to know if this kind of stuff was implemented in the systems engineering and safety engineering teams involved in this, and whether this was a contributor to some of those issues being missed and overlooked. I would be very interested to know that. I'm very skeptical about it. Yeah, because I've been in situations where we've had senior leadership get everyone together and basically say, right, from now on we're going to be agile and we're going to work in an agile way. Crack on, and then they've not actually provided any training or support or development of skills and agile. What would you call it? Agile behaviors and discipline. It's just click. You need to be agile. Crack on. And it's like, well, the way our work is not designed to support that method of working. So unless we're going to redesign the way we do things, we're basically going to be doing what we normally do, and then all this extra shit that, excuse my French, that doesn't actually mean anything to the real work we're doing. It's just admin burden and stress. Anyway. I would like to know more about that. That should be investigated. We should get that out in the open and say, right, for complex projects that are safety critical, how we implement changes to the way people actually do their work and their organisation should be done very carefully. So what did they actually do? How did they actually do that? Anyway, 1100 requirement series. So the crew transportation plan, technical management process, the crew transportation services requirements, the requirement interpretation letters, the technical standards and design evaluation criteria, transportation operation standards. Are there any safety standards? Safety standards, anyone? Where's my pen? There we go. Safety standards. Can't spell. Standards. That's right, isn't it? There we go. Insight oversight approach. Insight is defined as gaining an understanding of the commercial provider's requirements and activities and data through watchful observations, inspections, and interactions without approval or disapproval authority. So what is the point then? Is it just to be aware of the information? And it's not, from a safety insight perspective, you want to know what losses or accidents they're thinking about. You want to know what hazards they've identified. You want to be clear that they've got a good set of hazards that are properly refined and not just, I don't know, literally anything that has the potential to kill you. You know, you need to be specific. Then you need to look at the set of requirements they've got. Is it just probabilistic requirements, or is it just requirements for avoiding failures? You know, are there any functional requirements, any non-functional requirements, any timing or behavior requirements? What about the software? What about test specifications? What about the tests and the test results? Analysis results? And I think there should be a level of approval in that, because you're, part of the team, aren't you? Well, if they've done an analysis and you've had a chance to look at it and review it and provide comments on it, is that not part of insight? I wouldn't say that's oversight, unless you are literally, I'm going to review your stuff and I'm going to approve it. That's different. That's not quite the same. So again, the way this is defined, I think this is a bit ambiguous. I think it undermines the credibility of this shared assurance concept. Oversight approval. See, oversight is not the same as approval. Oversight is looking at it and going, yeah, what you've done looks good, and then someone else approves it. Because otherwise you've got a conflict of interest there. You're sort of setting the organisation up and the people involved to feel pressured to sign any old nonsense off. Now, I'm not saying that's what happened here, but I've seen that a number of times in the past. It's quite ridiculous. And of course, they don't like it when you challenge them. What do you mean you've got loads of comments? Your predecessor signed it off. They said it was fine. Well, I don't know how they managed to do that, because it's a load of nonsense. So you're going to have to do it again. Anyway, right. Fully engaged NASA technical effort focused on evaluation of contractors' evidence related to NASA product approval. Focused on completion of CTS certification, requirement satisfaction, VCNs, variance approval, hazard report approval. Again, what is this hazard report? What is it? What does it look like? What's its reference? How big is it? How many hazards does it deal with? What are the hazards related to propulsion? Approval and acceptance of performance milestones for core work and mission task orders through formally submitted contract deliverables. Commercial crew maintains a streamlined board structure. The Commercial crew and ISS programs have established a joint PCB for joint activities. So is this joint operational activities, or is this for design cooperation? What is that for? What is the scope? Right, so shared assurance, oversight activities, approval of contracted deliverables, milestones. See, this is program management, project management language. This is not about engineering or safety engineering. This is about deliverables and milestones. You know, this is just ridiculous. Insight activity, risk-based insight, risk-based assessment. Some things you have to check. It doesn't matter what you think the magical risk is. You have to check this stuff. Otherwise, you end up in exactly the situation we are here. It's ridiculous. For certain things, you can't put probabilities on it. So trying to do a risk-based anything is pointless. It's misleading. It's distracting. So yeah, I think that this is not appropriate, to put it politely. I think this is not appropriate for safety critical operations and designs. I think it's misleading. If you're making apps for the internet, you know, dating apps or something, then go right ahead. Be agile all you like. But for engineering complex programs, this kind of stuff doesn't help. It hinders. Anyway, I'll get off my high horse. Design certification is the authorization by NASA that the commercial providers' design and operations meet NASA requirements. Okay, so how do we know that NASA's requirement set is actually complete? Have they used STPA to derive those requirements or confirm they're adequate? And the other question is, do these design and operations meet the commercial provider's own requirements? Because the thing is, if you base certification on supplier, you must meet my requirements, and then we'll give you certification. What the supplier is going to do, and I've seen this a lot of times, you'll get senior program managers and project managers, and they will do everything that the customer wants. Whatever the customer requirements are, that's what they do. They don't actually bother to do the real engineering that they need to do to make the product actually do what it's supposed to do and be safe. They just do what the supplier says, and then they use the excuse of, oh well, you didn't tell us, you know, client, you didn't tell us we needed to do these things, so now you need to pay us extra to do the things that we should have known, we should have done and already done, if that makes sense. You know, I'm not saying that's what's happened here. I'm just saying in a lot of the programs I've worked with over the many years, that's exactly how the program managers work. That's how they make the money, especially if it's on a fixed price contract. They try their best to cause problems so they can make more money out of it because they don't get enough in the initial contract up front. And so all of this nonsense, it undermines safety and engineering. That's my experience. I've got too many arrows in my back. That's what it. Anyway, commercial provider is responsible for developing and executing its plan for certifying a CTS for its own use. Commercial crew with the ISS program. So this is the commercial provider, the commercial provider's design and operations. Commercial crew with the ISS program substantiate the commercial provider's certification assertion to ensure compliance with NASA requirements and NASA crew safety. Surely it should be up to the commercial provider to demonstrate that that's what they've done. Why should it be up to NASA to do that work? You know, the commercial provider should come to you with, look, this is what we've done. These are the requirements we've derived. These are the requirements you've given us, and this is what we've done for them all. Anyway, maybe I'm just misinterpreting what this is saying, but it just does not give me confidence. It doesn't fill me with a warm feeling that they've actually connected program level activities and actions to the safety engineering of the program. Anyway, let's go. COFR is the authorization by NASA that grants the use of test-specific, mission-specific commercial providers, CTS hardware, software, and operations team to transport NASA crew to and from the ISS. Commercial provider is responsible for developing and executing its plan for certifying a CTS for flight readiness. Is it not certification for safe flight, not just flight readiness? I don't know. Commercial crew with ISS programs substantiate commercial providers' COFR assertion to ensure compliance with NASA requirements and NASA crew safety. Isn't that not just the same? So design certification is the authorization by NASA, and COFR is the authorization by NASA that grants use of certain things. Right, so that's about meeting requirements, and this is about authorization. To do stuff. Authorization to do. Authorization by NASA to transport NASA crew. Whereas this is authorization by NASA that they meet requirements. Okay. Commercial crew metrics and decision structure. Commercial crew PCB topics 2010-2024, so 14 years, includes joint ISS PCB topics. So we've got Boeing, and then we've got other, and then we've got SpaceX. Which is interesting because it said earlier on that they were doing loads of stuff during the 2010 to 2014 time period. And then from the 2012 period, they were doing preliminary design review and critical design review, 2013, 2014 to 2017. So 13, 14, 17. Let's have a look. '13, 14, 17. So there's 2013. There's 2014, and then up to 2017. So in that time period there. So Boeing didn't. Okay, that's interesting. So there quite a few. And then even more in 2018, 19, 21, 22, 23, 24. So the PSB is the approval authority. So that is a key, that is certainly an element that should go in the control structure model. So the Program Control Board is the approval authority for establishing program technical requirements, documents, schedule, safety and risk acceptance, and for any changes thereto. It also has the final assessment of the crew commercial provider's progress at the performance milestone reviews, manages the government's investment risk, and determines success or actions needed to mitigate or accept identified gaps. The PCB approves contract change requests and new internal agreements with other NASA programs, institutional officers, and external agencies. The PCB is responsible for the approval of the following applicable programmatic documents that require the program manager's signature: baselining or revising applicable data requirement deliverables per the DRD review process, baselining or revising requirements, verifications, exceptions, deviations, or waivers to program requirements, adjudication of issues affecting crew health and safety and mission success. Changes to program baseline schedule milestones, CTS design, development, test and certification issues, and COFR recommendations. New agreements or changes to existing agreements and contracts, milestone approval and direction for associated payment, risk assessments of the CCTS and approval of any risk above baseline. So when it says risk assessments, are these program risks or are these safety risks? What risks are we? What risks are we talking about? Program or safety? What are we talking about in there? What is that? Evaluation of design analysis and safety assessments. Yeah, there we go. That's an important one. Milestone readiness and closeout for commercial providers, technical reviews, other items as determined by the PCB chair. Okay, so yeah, I mean that program control board is absolutely critical to the control structure. And it sounds like a lot of the issues that got through and essentially ended up in a flight with people on board, the PCB is the approval authority for all of that. So why was the PCB approving these things? If they are, responsible for the approval of the following, when we say approval, what do we mean? Do we mean technical approval? If they've been technically approving the safety assessments and they're missing things, then what's going on there? What is the PCB chair doing in that respect? We need to find out. We need to investigate that. We need to understand. Okay, let's have a look. So we've done that. Now there's crew commercial CPC letters. So we've done certification strategy, crew metrics and decision structure. Is that right? Is that this bit? Yeah, I think it is. Okay, so commercial crew, CPC letters and CTP directives 2010, 2014. So Boeing is the blue one, SpaceX is the red one, as you can see there. So there's loads of letters, apparently. So 2013, there was loads, 2014, 2018, 19, 20. I don't know what the relevance of this graph is, including SpaceX. Why is that important to this? What are we trying to show? Are we trying to show that SpaceX sends more letters? Is that good or bad? Is it even relevant to this? Because we're talking about the Starliner. We're not talking about the SpaceX's spacecrafts. Why is that important? I don't know. It's also interesting that they didn't start until 2013. So this graph implies interactions between NASA and the commercial crew providers. That's my impression. And it shows that there's a load of them over a year. A commercial crew program directive is the mechanism for transmitting management or board direction to the program supporting organizations and commercial providers in the conduct of the CCP during the CCTP cap era. Okay. So it's mechanism for transmitting stuff. So I wonder if there's any issues with that. Maybe they were aware and documented these non-compliance issues, these certification issues, but this mechanism didn't work for whatever reason. Is that something we need to think about? A CPC letter was the mechanism for transmitting DRD decisions to the commercial providers during the CPC era. So that's the CCT. Oh, God. Why can't they just give them numbers or names instead of ridiculous acronyms? CCT cap era, CPC era. The CCP manager, CCP manager or any commercial crew organization can identify the need for a directive. Directives require the program management signature. Directives for ISS designated in that requirement are integrated and therefore additionally require the ISS program manager's signature, delegate, or reference to the ISS approval documentation. Directives are required for approval of risk acceptances and closures, unexplained anomalies, and in-flight anomaly closures. Certain DRDs unallocated, so there's certain documents, unallocated future expenses, and all variances and alternate standards except Category 2 material usage agreements. Okay, so this is the process for sending these control actions and getting feedback around the control structure. That's quite interesting. I'm quite impressed that they've included that level of detail. That's pretty cool. Commercial crew total boards and panels. So number of boards and panels. So not, yeah, okay. So not in 2010 seems a bit odd. So loads and loads and loads, and then it's tailed off. Okay. Another observation. These graphs are really interesting, but it'd be nice if it was sort of clear why that information was included. Why is it relevant? What are you trying to tell us by including this data? So what? Are we trying to imply that there's not enough boards, or there's too many, or what are we doing with that? So here we go. Oh, look at this, everybody. We've got a structure. Yeah, we could use this to influence our control structure model. So let's have a look. We've got the JPRCB. What the heck is one of them? JP, it's not even in the... JPRCB, PCB, SSPCB, TRB, STRB, TICB, SRP. Integration forums, engineering review boards, panels, and working groups. So CCP board structure. Okay. Description of the lower board. The technical review board supports the PCB. Ah, there we go, look. Technical review board, everybody. There we go. Right. Supports the PCB with the technical management, systems engineering, and integration program requirements which have not been delegated to the Commercial Crew Safety Technical Review Board. So commercial crew. I think what I'm going to do is I'm going to start writing about these, because I think these are definite candidates for including. So JPRCB, joint something, don't know. Program control board, PCB, and then we've got the technical review board, TRB, and then we've got the commercial crew safety technical review board. So this is the STRB. Right, great. Okay. The TRB mechanism is the TRB is the mechanism that technical authorities and supporting organizations utilize to obtain technical decisions for commercial crew. The TRB will meet jointly with the ISS Technical Integration Control Board. Interesting. So the ISS Technical Integration Control Board. Oh, God. TICB. Right. When requirements and risks impact both programs. So does that mean then at the TRB you've got the ISS TICB and the commercial crew STRB getting together to discuss the qualification issues and that it wasn't qualified. Did they even know that? Was that on the agenda? Is that in the meeting minutes? Is it on an action tracker to be sorted out? I find it hard to believe some of these issues would just find their way through the bureaucracy in this way. So what do these organisations know about these issues? Maybe it will come out in the next few sections. The STRB, so let's just get my pen and highlight that. So that one and ISS TICB. The STRB supports the PCB with the technical management, systems engineering and integration for designated program safety requirements. Right, so this is it. This is the important one here. Designated program safety requirements. So if you did an STPA, they would take those safety requirements and constraints and the high-level safety constraints and the hazards and make sure that they are dealt with throughout the program. That's my impression. Right, so the STRB provides review and oversight of delegated safety and technical requirements, activities, and safety products associated with ground and flight safety of CCP CTS by assessing safety and or technical risk issues. So they are the people that would, should know, could know. The STBR is the mechanism that technical authorities and sporting organisations utilise to obtain safety-related decisions for commercial crew. The STRB is responsible for review and approval of the ground launch vehicle, spacecraft and landing recovery hazard analyses. Right, that is interesting. Along with all integrated hazard analysis and supporting documentation. The STRB works in coordination with the ISS Safety Review Panel. So they are there, look, everybody. Yeah, okay. Where safety and technical risks issues impact both programs. For safety topics affecting both programs, a single integrated review process for CCPS, TRB and ISS SRP is implemented to review and approve integrated safety risk issues. Right, so it sounds like they would be involved in the design and development issues and presumably the operational issues, operational decision making. So in terms of interviews, those groups are the people that I would want to speak to if I was doing the investigation, to try and understand what did they know, what did the hazard analyses, safety analysis reports contain? Did they consider these issues? If not, why not? If they did, how was that information flowed and how did it influence decision making? The ISS CCP Joint Program Requirements Control Board. That's what JPRCB is. There we go. Look at it. So we've got JP, so Joint Program Requirements Control Board. JPRCB ISS CCP. There we go. Bit of a mouthful. Is responsible for the approval of joint program documentation, agreements, processes and milestones, and for the final disposition of joint technical and programmatic issues and changes. So again, that board is a controller that we'd need to look at and understand What were the control actions? What were the decision making they were doing? What beliefs, mental models did they have? What feedback did they have? What directions did they have? The verification and validation panel supports the program boards by offering guidance on the planning and execution of requirement 1130 verifications and system validations and assessments of risk in the verification and validation methods, activities and schedule. So they will be useful. Why are they not on there? Anyway, program organizations utilize forums to review and discuss significant technical topics, integrate across the organization, and formulate joint office stakeholder positions for office decisions or program boards and panels agenda items. After agency flight readiness review for each mission, PCB meetings will be held to close any open items from approved COFR exceptions. The purpose of these PCBs is also to report on the status of any open work and actions from the agency FRR prior to commercial providers' launch readiness review. Okay, so were those qualification issues open? Did this organization, this stakeholder, this controller provide that information to the PCBs or to the decision makers? If not, why not? What's going on? After the LRR, each of the commercial providers' mission management teams, the Dragon DMT chaired by SpaceX and the supplier Starliner, Boeing, are established and operate until after crew handover to NASA post-landing. Any open items from the commercial provider LRR will be addressed at the SMT and elevated to the agency if required. The commercial crew mission management team. So this is not the same. Oh God, my brain's going to explode. Right, so there's a Starliner one, and then there's the commercial crew one, and then there's the Dragon one. Okay. Is the mechanism that the technical authorities and supporting organizations interface with to obtain technical decisions for CCP during real-time operations missions as defined by the crew transportation plan. So this is really important during real-time operations as well. The DMT and the SMT is the decision-making body, respectively responsible for programmatic trades and decisions associated with launch countdown, in-flight activities, landing and recovery. NASA CCP has a voting member, NASA operations manager, on both teams. Yeah, we touched on these in previous live streams. According to the specific plans of each commercial provider, and maintains its authority to approve acceptance of any risk to the crew safety, vehicle safety, and mission success above the nominal baseline as defined by the agency flight readiness review. The NASA operations manager receives input from the crew, commercial crew, MMT members. I mean, is there an organization chart for that? Because it sounds blooming confusing. So we've got the after agency. Oh gosh. Flight readiness review. And then we've got agency flight readiness review. And then we've got commercial provider mission management team, MMT. And then we've got Starliner Mission Management Team, SMMT. Then we've got Commercial Crew Mission Management Team. It's just MMT. Then you've got Technical Authorities, and then you've got NASA Operations Manager. NOM. There we go. So all of that is sort of the higher levels of the control structure above the actual vehicle and the crew. And then off to the side of that, you've got all of these PCBs and SRPs and everything else from a design development perspective, but also overlaps with the anomaly issues. Where is it? Where's the bit about anomalies? Where's the word anomaly gone? There was a bit about anomalies, wasn't there? I'm sure there was. Where is that word anomalies gone? Yeah, okay. So that's quite a lot. Right. So that is up to crew commercial timelines. So let's just have a look. Crew commercial timelines. There we go. So we've done that. Right, I'm just going to have a quick 2-minute break and grab a fresh drink. So just bear with me while I do that. And I'll be back in a few minutes. See you in a second. And I'm back in the room. Is my audio working? Yes, I think it is. It's just so frustrating when you're busy chatting away and you're on mute. You know the reason for that? It's because there's missing feedback. Because I don't have my voice going through the microphone and into my headset, and I probably should do. The reason I do it this way is to avoid feedback with the speakers. So if I have my speakers on with my microphone, of course, there's a potential for them to feedback. So that's why I've got my headset on. So what I need to do for next time is I need to figure out how to pipe this into my ears, and there's minimal lag as well. Because of course, this is a USB microphone, so the voice gets converted into digital signals that then come out the computer. So excuse me. So there is a time lag between me speaking, it being picked up, and coming back into my ears. So what I need to do is have a closer, smaller feedback loop, so that there's no lag, and I can immediately know whether you can actually hear me or not. Because it's all right having the levels flashing up and down, but if I'm too busy looking at the work and getting excited, I'm just going to miss it. So I must apologise for that. That was about 20 minutes we lost, but hopefully for the last, while we'll hear, I won't do it again. So yeah, let's see what happens. Unmute. Right. Where were we? There we go. So, so we've done that bit and this bit. We've got all of this still to do, but we're getting there. We're getting there. We've made fantastic progress today, certainly. So let's talk about crew commercial timelines then. So we've got the overall commercial crew timeline of events. So this is from 2024 all the way through to 2010. So 14 years. That's a lot of work. So program events at the bottom, and then Boeing contracts and stuff at the top. So do I really need to go through this in all this detail? Let's just have a quick flick through. So we've got, okay. Abort architecture trade, PDR, service module propulsion, PDR 2011-2012. Then we've got another PDR, Oh, there's the other propulsion RCS stuff. So the OMAC, orbital maneuvering and attitude control, reaction control system, TDR, technical design review, is that? What's a TDR? Come on, what's the acronym list say? Of course, it's not in the acronym list. Ugh. Anyway. CDR 2013. CBR, don't know what that is. Is it a spelling mistake? Don't know. P2 safety review. Prop Tim 1, service module RCS thruster. Valve MRR phase 2, STRB. Oh, so these are these reviews. So the STRB and the TRB and the PCB. Let's just copy those. Bring them across here. Paste it up here. There we go. So we've got, what have we got? Phase 2 STRB, so Commercial Crew Safety Technical Review Board. Delta CDR, SM Prop, Propulsion. So all this CDR and Delta CDR and SCDR, all of those things, they are little red flags to just highlight there's something not quite right with the program here. Now, I'm not saying that we shouldn't have, multiple reviews. What I'm saying is if you're having a preliminary design review and then you're having a critical design review and then there's loads and loads of other reviews after that, that suggests there's something not quite right with the program and or the engineering. Was it that it was pushed through PDR too early? Or was it just a rubbish design, perhaps? I don't know. It's just a telltale. When you've got program issues like this, it's just a telltale there's something not right. So we shouldn't be surprised if we're having issues later on, is all I'm saying. QTV, production, prop, test, OMAC, SM Hotfire 1, SM Hotfire 2, RCS qual testing. So that was 2718. SM Hotfire abort test. OFT, FTRR, OFT1, so that was 2019. OFT2, OFT2 scrub, OFT2, CFT DCR, CFT DCR, CFT FTTR partial, CRR, HRCP, CFT, oh gosh, all of those, crew flight test. So between 2017 and 2024, what was going on from a propulsion qualification and safety assessment perspective? Maybe this timeline doesn't show that detail. Because one of the things I'd look for is I'd look at the safety management plan and I'd look at the safety boards, what do they call it? The Commercial Crew Safety Technical Review Board. Is it the STRB? Is that the... Yeah, the STRB. So what is going on with the STRB? Are they, having meetings regularly? How are the actions been progressed? What is the timeline for that board? And again, this is the overall Commercial Crew timeline, of course. So is there another timeline that covers the safety aspects, the safety cases and all that kind of... Sorry, not safety assessments and all that kind of stuff. And then from a program events perspective, we've got 1100 requirement series baseline, pad abort test. Don't know what all this stuff means. CRS, don't know. Oh, these flights, human flights, are they? Crew 1, Demo 2, Crew 3, Crew 2, Crew 4. Oh, right, so they've done loads of crews. A lot faster as well. Interesting. What is it about the control structure for the SpaceX stuff? Why is that so much apparently faster and more effective? What's going on there? Is it because their design is more mature? They've done it before? It seems a bit odd. That would be one of the recommendations from a programmatic perspective. Go and look at the control structures for what SpaceX is doing. And how is that different to what Boeing is doing? You know, what are the overlaps? What are the gaps? And I can appreciate two different companies will do things in different ways. Totally get that. But they still have to perform the same functions. So what is it about the structure? What is it about the behavior of the controllers that leads to this difference in performance? Or is it, and I've been, rhetorical question, I've been very facetious here, or is it that SpaceX would just do everything faster and cut loads of corners and they've just been lucky enough not to have an accident yet? I'm not saying that's the case. I'm just saying that that is another alternative here. Let's the question, the answer should be, let's go and look at the control structure of each of these and understand what's going on. I've been very facetious. That's one thing that you'll get to know about me is I can be a bit sarcastic and a bit facetious. Ultimately, my heart is in the right place. I want to help. I want people to get better results, faster results, quicker results, better results, and ultimately have a safer, faster, better program that makes more money. Let's get to space and do well at it. Let's not have lots of accidents and waste lots of money, time, and energy and tears. Let's not do that. To accurately trace back to full-on implementation is critical to understand the timeline for Boeing design decisions versus NASA engineering capacity to influence and assess these decisions. NASA requirements, Boeing of tailoring of requirements, how components actually functioned and were tested versus Boeing early design decisions must also be considered. Add to this Boeing's limited ability to see specific supplier information and limited flight experience ensured significant discovery was inevitable. Yeah, I think that's a fair point. Timeline for observations. So SAA awarded, SM Propulsion System, SDR. So the ones I'm interested in are this one and the safety assessments that led to that. That one. DCDR, what's a DCDR? That one. Yeah, there we go. So how did they get to the point that they should go flying? How did they get over that barrier? Let's use my pen instead. See if it's nicer. There we go. How did they get across there? Right. Okay, so that's all of that stuff. So that's crew commercial timeline. Right. So now we've done all of that. I think we've made some good progress there today, everyone, to be honest. I don't know about you. How long have we been going then? 2 hours 55. It says on LinkedIn. What does it say? Where's the time? 2 hours 56, 57. Right, let's keep going. In fact, let's just zoom out and have a look, because I could probably have a break at 8 o'clock, couldn't I? Let's just zoom out a bit. Ah, right, okay, so we have made significant progress then today. Amazing. Or amaze, as Rocky would say in the film Project Hail Mary. If you've not seen the film, I do recommend it. And if you've not read the book yet, I'd watch the film first and then read the book, because the book is way, way more detailed than the film, as most will be, as you expect. Okay, what's this? Focused crew flight test, SM Propulsion Anomalies timeline. Okay, so what have we got? So 2024, 2010. Awarded. Propulsion PDR, yeah, okay. There's another PDR there. CDR, CBR, CDR, I don't know what that is. Oh, safety review, yeah, safety review, 25 to 2019. Okay, what does that mean? Why is that so big and long? Why is that so? That's like 4 years. Was it that difficult and complicated that it took that long? Or am I misinterpreting things? I mean, that doesn't make sense to me. Anyway, HR's 208-1601 phase 3 approved for OFT only. So if it was approved for OFT only, and well, what happened between here and here then? Because is it that they thought that they'd done all the safety work to include qualification for crew flight? Or is it that they got it done for OFT standard and then they had to do loads and loads of work? But then they had loads of incidents, didn't they? Yeah, there we go, look. So there's valve failures there. So why wasn't a safety review done? Or did they do it? It's just not on this list. And then again, what about this? Lack of two-fault tolerant acceptance. Yeah, there's a lot of stuff missing from this. This raises a lot of eyebrows and questions. It doesn't seem like the safety program based on this information is really clear. Is it because it's not clear, or they've just not included enough information for me as a layperson to understand? But I'd want to dig into that even more. I'd want to understand more. Okay, right. General findings, everybody. So we've done that. Yeah, it's a timeline, but they don't really say much. Right, let's have a look. General findings. So there's quite a lot of that there, isn't there? Let's have a look. I think maybe this might be a good point to have a break. Let's just read this page. In fact, no. Let's pull the stumps there, because this looks like we ought to start with this next time. Let's pull stumps there. I hope you found that interesting. I mean, that's quite a tough one to go through today. It's a very long live stream. It's basically 3 hours. It is 3 hours now, exactly. And we're going to carry on tomorrow, Friday, what day is it tomorrow? The 7th of August, 1800 UTC +1, so 6 p.m. And we'll go for a couple of hours, see how far we get. And then once I've got through this investigation report, I will send an email to everybody who is on the waiting list. And if you're not already on the waiting list, let me just stick that in the chat for you. Join the waiting list for the free live workshop. And then we can get together on that workshop and talk about this to our heart's content. There we go. There's the link. But anyway, thank you very much for your attention. Thank you for watching. Thank you for your comments. And I will see you tomorrow on the next live stream. Have a good night. Take care.